This video is kind of an addendum to the last video from section 3.3. I gave you guys the logarithmic properties, but this video is going to talk about why those work or how those work. I think that your book actually does a really excellent job of explaining this in the proof of mathematics section, which is on page 258. So if you don't really feel like watching this video, feel free to check out that page. Honestly, all I'm going to do is use the examples and the proofs on that page to explain this. Let's start with the product property. And really, for all of these, there's some assumptions we're going to make that we're going to basically do algebraic proof. Let's go ahead and say that log base A of u equals x, and log base A of v equals y. We're going to kind of use this all throughout. So for the product property, we know that log base A of u v equals log base A of u plus log base A of v. All right. So I'm going to take the things that I wrote up here and I'm going to rewrite it in exponential form. Log base A of u equals x. Well, if I rewrite this in exponential form, that means a to the x equals u. Okay, that's important. And since I said that log base A of v equals y, this means that a to the y equals v. So I know what u and v equal. I also know what x and y equal. I just kind of have them in their different forms. Earlier, I asked you to find the log base A of u times v. Well, let's talk about what u times v equals. If we use our definition up here, u is the same thing as a to the x, v is the same thing as a to the y. And because we know our exponent rules, we know that a to the x times a to the y is a to the x plus y. You might be able to see how this is going to relate. Now let's go back to the beginning. In the very beginning of this, I said the log of uv equaled something. Well, just now I proved that uv was the same thing as a to the x plus y, right? So that must mean this. Just as a reminder, the reason is because if I rewrote this in exponential form, it would be a to the x plus y equals uv. And that's exactly what I just stated above. So here it is in logarithmic form. And then if I take it one step further, just to prove things algebraically, I know what x equals and I know what y equals. Earlier, I stated that x was going to be the log base A of u, and y is the log base A of v. And I'm actually back to the beginning. So I essentially used exponent rules to prove a logarithmic rule, which is what I alluded to in the last video, but here you have the actual algebraic proof. Let's use the same assumptions about what u and v equal to prove the quotient property. Instead of starting with u times v, let's start with u over v. We already discovered that u is equal to a to the x and v is equal to a to the y. And now we know, because of our exponent rules, that this must mean a to the x minus y power. So u over v equals a to the x minus y. Let's rewrite this in logarithmic form. This is going to be the log base A of u over v equals x minus y. Notice the base is a, the answer is u over v, the exponent is x minus y. So that's what that means. And then again, I can take this one step further by plugging in what I know about x and y. So this is where I left off. And earlier I stated that x was equal to log base a of u, and y is equal to log base a of v. So I've just proven the quotient property. And let's do it one more time with the power rule, or the power property. And here's what I have. Log base a of u to the n power. All right, well, let's plug in what we know about u. We've already stated that u is equal to a to the x power. So notice all I've done is replace u with a to the x. And I know from my really basic properties that when you take the log of something that has the same base, you're just left with the exponent. So this is the same thing, first of all, as this, xn or nx, which means I'm going to be left with xn. And x is the same thing as log base a of u. So I'm going to rewrite this way with the n in the front, just so it looks like what we're used to it looking like. So I just proved that these two are the same thing. Basically, the exponent just moved to the front. And that is the proof of the 3 properties that we talked about in the last video. Woohoo!